Steps for solving exponential equations. First, you're going to isolate the exponential part of the equation, so that's the part with the base raised to a power. Secondly, you're going to log or natural log both sides. Third, you're going to use the power property that you just learned about to bring that exponent down in front. And then fourth, you're going to solve. So in example 1, the part that we're going to try to isolate, you see 8 is the base, and it's being raised to k plus 5 power. So in order to solve for k, what we're going to first need to do is get this over here. So first we're going to subtract 6 from both sides. And what we've got is a to the k plus 5 is equal to 51. Step 2 is to log or natural log both sides. You honestly could use log of any base. You use natural log a whole lot in pre-calculus and calculus, so I'm going to go ahead and start trying to get you in the habit of using natural log. So you're going to natural log, so you just sort of put an ln in front of what you've got going on each side. So this becomes the natural log of 8 to the k plus 5 is equal to the natural log of 51. Keeping in mind that golden rule, whatever you do to one side, you do to the other. Next, I'm going to use the power property that says that if log is there, I'm allowed to bring my power that's up here down in front. So that gives me k plus 5 times the natural log of 8 is equal to the natural log of 51. So now I just need to solve for k. Since this is being multiplied and I want to get this away, I'm going to divide both sides by natural log of 8 and bring down that k plus 5. So I've got k plus 5 is equal to the natural log of 51 over the natural log of 8. And it's supposed to be natural log. Alright. And then, last step, to solve for k, I'm going to subtract 5 from both sides. And that gives me that k is equal to the natural log of 51 divided by the natural log of 8, and with 5 being subtracted for that whole thing. And this by itself is how you might see an answer in a multiple choice test. You also might need to approximate it. So if you practice putting that in your calculator, you should get a value of approximately negative 3.1091. And for whatever reason, a lot of what I've seen with these approximate it 4 decimal places. So it's a good idea to do all 4. Okay, example 2. Your first step is to isolate the exponential part of the equation. Well, our exponent is here, and we have the base of 9. So we want to get that base isolated. Negative 10 is being multiplied to it. So the way we're going to get rid of that negative 10, the inverse of multiplication is division, so we're going to divide both sides by negative 10. Next, we're going to natural log both sides. Now that log is on both sides, we're going to bring that power down front using the power rule. It's one of those amazing properties of log. You're just allowed to bring an exponent down in front. That's why it's so cool. Alright, and lastly, because I'm trying to just solve for p, both of these are being multiplied, which means I could divide by both of them. So I'm going to divide by negative 9, natural log of 9. So the negative 9's cancel here, the natural log 9 cancels there, and I'm left with p is equal to the natural log of 2 divided by negative 9, natural log of 9, and that approximate answer is a negative 0.0351. Okay, that's it.